Hi, welcome to another video. So this video is on predicting stereoisomers. So the compound we're looking at today is 2-bromobutanoic acid, and we want to predict how many stereoisomers there are. So first of all, let's draw out 2-bromobutanoic acid. So bute is meth, eth, prop, bute. Anoic acid would be a carboxylic acid. And on the second one, carbon from the carboxylic acid is a bromo. So this is our compound here. So I'll draw out the full structural diagram so you can see everything that's bonded very clearly. Now what we want to do is find the stereo centers or chiral carbons. So chiral carbons are a carbon that has 4 different groups attached. So 4 different groups. So if we look at this carbon here, it's got 3 hydrogens. They're all identical, so it wouldn't be that one. This carbon here, we've got 2 hydrogens. They're identical, so 2 groups being the same means we can't have 4 groups that are different. The next one here, we have a hydrogen, we have a carboxylic acid, we have an ethane chain, and we have a bromine. So we've got 1, 2, 3, 4 different groups attached. So this one here would be a chiral carbon. And the last carbon we have is the carbon of the carboxylic acid. It has a double bond going to the oxygen, so it doesn't have 4 different groups attached because 2 are used going to that oxygen. So we've got 1 chiral center. So remember, you can get an R or an S configuration at a chiral center. Now the general rule is 2N, N being the number of chiral carbons. And this will predict how many stereoisomers you can have for this particular compound. So our N value here for this example would be 1 because we've got 1 chiral carbon. So 2N would be 2, 1, which would equal 2. So we can have 2 possible stereoisomers, your R and your S, okay? So of this carbon here. So for larger molecules, if you remember, identify the chiral carbons and know that 2 to the power of that number will give you the total number of stereoisomers for that particular compound. So thank you for watching this video, and I'll see you next time.